In this video, we're going to learn how to solve these WASSCE chemistry problems under electronic configuration. So guys, we have about 18 repeated questions to practice with in this video. Let's get started. The first question I have here says, which of the following electron configuration represents that of an atom in its ground state? So ground state is a state that is not excited. So basically it has to be an inert element which has no excitement. So let's check the one that is inert here on noble gas. So the one here is this one. This option C. 1s2, 2s2, 2p6, 3x0. So this is neon. Alright. The next question will be this one. It says the electrons that are most easily moved from this magnesium and in which orbital. So that's the electron that are in the atomic shell. So magnesium has 12 atomic number. So if I presenting it in the orbital, so you're going to have 1s2, 2s2, 2p6, 3x2. So it will be in the 3x orbital. Alright, option B is the right option. 3x orbital, where in this 3s the number of electrons is 2. So that 2 in this 3x, that 2 number of electrons in this 3s is the number of electrons that is easily moved. Okay, so it's in the 3x orbital. Next the question, this one, it says which of the following atoms contain the highest number of electrons in the Atmos shell? So it will be neon atom. So potassium is in group 1, so it has 1 electron in the Atmos shell. This phosphorus has 5, this oxygen has 6, and this neon has 8 in the Atmos shell. So the right option is option A. Next the question with this one. It says the electron configuration of carbon atom in its excited state is. So the right option here will be option A. Okay, so guys, take note of this question is option A. Okay, it gets repeated again. The right option here is option A. Alright, so that is for this question. The next of the question will be this one. It says how many electrons are in the L shell of this? So this is phosphorus. So if you are representing it, the electronic configuration value, you're going to have 265. No, you're going to have 285. Alright, so the 2 is for the K shell, the 8 is for the L shell, and the 5 is the M shell, the M. So since you're looking at the L shell, so the value there is 8. Okay, 285. So the L is the 8 value. Option D, the right option. Next with the question will be this. It says the atom with the electron configuration is in. So is basically in period 4 and P block. Yeah, I can remember this question. Remember, this is a repeated question, so I've come across it again. The right option is option D. When I came across it the first time, I realized that the answer was this option I'm choosing, so I'm choosing the option again and I verified it. So the right option is option D, period 4 and P block. Alright, so that is the right. So that's it for this question. The next question will be this one. It says the energy change which accompanies the addition of electron to a gaseous atom is electron affinity, option B. Next question is this one. It says how many unpaired electrons are there in an atom of element with the following electronic configuration? So this is neon. Okay, we have atomic number of 10 here. So neon is noble gas. Noble gases have no unpaired electrons. All the electrons in it are paired. Okay, so the right option here is D, 0. So there is no unpaired electron. The next repeated question, this one, it says which of the following electron transitions results in the emission of energy? So when you talk about the emission of energy, from the options we have here, so the emission of energy will occur from the highest orbital to the lowest orbital. So the right option here would be option C, which is 3p to 3x. So you're going from the higher orbital to the lower orbital from 3p to 3x. Okay, so that's it for this question. Emission of energy occurs when there is a transition from a higher orbital to lower orbital. Okay, which is option C here. Next question will be this one. So guys, before I attempt this question, if you are new to this channel, ensure that you are subscribed to this channel by hitting the subscribe button for more of these videos. Really appreciate this. This question says, which of the following represents the ground state electron in the configuration of an element with atomic number 6? So this is carbon. Basically, it has 6 atomic number. So if I'm representing this in orbitals, so the right option will be this option C. Yeah, so this is the right option C will be the right option to this question. Very important, guy, in case it gets repeated. So next question will be this one. It says an element with the electron configuration would have a combining power of 0. So this is a noble gas. This is neon. Alright, atomic number is 10. 6 plus 2 plus 2, that's 10. So noble gases or inner gases have no combining power because they already have stability. Alright, so they don't need to get into reaction again. So the next question is this one. It says which of the following ions has an electron configuration different from the other? So from what we have here, the right option is option B, which is chlorine ion. Alright, so this aluminum ion is taken by chemical reaction, so it will lose 3 electrons to form noble gas of neon. Same thing is applicable to magnesium. It will take part in chemical reaction and lose 2 electrons to form noble gas of neon. This oxygen gas, a non-metal, is taken part in chemical reaction to gain 2 electrons to form a noble gas of neon. But this chlorine here is taking part in chemical reaction, gaining 1 electron to form a noble gas of argon. This oxygen is taking part in chemical reaction, gaining 2 electrons from noble gas of neon. So the exception here is option B, chlorine charged atom. Okay, this one is forming argon, not that are forming neon, only chlorine is forming argon. Alright, so it's a different one. Which of the following ion has an electron configuration different from the other? So it's chlorine charged atom here. So next question, this one, it says what is the electronic configuration of an element represented as this? So this is fluorine. So the right option is option A, 5 plus 2 7 plus 2 9. So fluorine has atomic number of 9. Next question will be this one. It says which of the following element has a ground state electronic configuration with an incomplete penultimate shell? So the right option is option C, which is ion. Alright, the next question will be this one. It says the energy which accompanies the addition of an electron to an isolated gaseous atom is, so it's still electron affinity. Okay, next question is this one. It says how many unpaired electrons are present in this ion, charged ion? Cool. So it will be 5, guys, basically, because this ion is losing 3 electrons as it's taking part in chemical reaction. So the atomic number now will now be 23 instead of 26 when it loses 3 electrons. Okay, alright, so when I'm representing this electron in orbitals, we're going to have that the number of unpaired electrons will be 5 when you represent it. Because of time, I can't do it now, but just know that it's 5, option D. Next question with this one. It says which of the following electron configurations correctly represents an inert element? Alright, so it will be option C, 6 8 10, which is neon. Okay, so the next question will be this one. It says which of the following is a configuration of sodium ion if the atom is represented as sodium atom. Alright, this is neutral. So the charged sodium, the electronic configuration would be, if not have the structure of a noble gas, it should not be this option C, 6 2 10. That's neon has 10 atomic number. Since we are looking for the charged sodium, it will now be 10 atomic number because it's going to lose one electron. Alright, when you lose one electron, it's going to have a remain of 10 electrons. So when you present that 10 electrons in orbitals, this is the output: 1s2, 2s2, 2p6, having the structure of a noble gas neon. Last question before I end this video with this one. It says the number of electrons in 3d orbital of chromium is, so chromium has to the atomic number. So when you represent this in orbitals, so the 3d orbital is going to have 5 electrons basically. Yeah, it's going to have 5 electrons. So it's as simple as this. Basically can do problems involving electronic configuration for your WASSCE or WAEC chemistry. That's with about 18 repeated questions in this video. Hope you learned something interesting from the video. Let's go to the video, guys. If you are new to this channel once more, ensure that you are subscribed to this channel by hitting the subscribe button for more of these videos. So like, share, comment on this video. Tell me how you feel for what you learned from this video. If you seem to have any specific questions to ask regarding what I talk about in this video, feel free to leave your question in the comment section below, and I'll be sure to give you a response. So ensure that you're part of the channel membership by clicking the jump button, where you'll be getting premium information that will help you to excel in your next exams like your WASSCE and other exams you'll be writing. Okay, so having known this, click the link above and I'll see you in the next video. Thanks for watching.